Ask anyone who fishes, and they'll likely tell you a highly exaggerated story about the one that got away. You know, the absolute monster catch that snapped the line right at the boat. Losing a massive catch is definitely a bummer for the angler, but letting those huge fish slip away is actually critical for both the survival of marine species and the future of the fishing industry itself. To understand why, you have to look at how we currently regulate the water. For most commercial and recreational fishing worldwide, the baseline rule is a strict minimum legal size limit. The enforcement is simple. If you pull up a fish and it falls below a specific threshold, on the measuring tape, you are legally required to throw it back into the water alive. From small-town docks to international waters, modern fishing regulations rest on a single assumption, that saving the small is the only way to save the stock. On paper, the logic behind these size limits makes perfect sense. The goal is to protect juveniles, keeping them safe in the water long enough to grow, reach maturity, and reproduce at least once. If we ensure the youth get a chance to make babies, biological math suggests there will always be enough adult fish swimming around for tomorrow's dinner. That logic is incredibly old. The British Parliament was officially debating ways to protect young fish from nets all the way back in 1376. But despite hundreds of years of global adoption and what seems like flawless common sense, this conservation method is biologically broken. Humanity's oldest, most widely accepted fisheries law is actively damaging the very marine ecosystems it was designed to protect. The problem starts with the fact that reproductive math isn't a simple one-to-one ratio between small adults and massive adults. Egg production scales exponentially with size. This means the largest, oldest fish in the water produce drastically more eggs than smaller adults that have just reached maturity, and those eggs are physically superior. The eggs produced by enormous fish contain a significantly larger internal food supply, giving the newly hatched babies a much better chance at survival in the open ocean. This diagram compares the massive volume and larger size of eggs from one giant fish against the meager output of an entire school of smaller adults. By setting a minimum size limit, our laws legally mandate specifically targeting and removing these highly fecund individuals. When we keep a single massive fish, we are effectively deleting the population's most efficient engine for biological replenishment. Beyond wiping out the best egg producers, these strict rules create a second, highly destructive biological effect: accidental artificial genetic selection. By pulling out all the largest fish and consistently throwing back the little ones, we apply intense survival pressure that favors fish genetically predisposed to be small for their age. Because they grow slower and stay under the legal size limit longer, these smaller fish are legally protected right up through their reproductive cycles. Look at this genetic flowchart. Large gene fish are consistently removed by nets, while small gene fish filter back down into the ocean to multiply, passing those traits to the next generation, while big fish genes disappear. We have unintentionally built a highly efficient, human-engineered breeding program completely optimized to shrink marine life. These genetic shifts are occurring at high speed through a process called size-selective fishing. Over just the last 40 years, the total body mass of large commercial fish species has been cut exactly in half. This bar chart tracks the average mass of a 6-year-old haddock over time. Today, it weighs only 40% of what it did in 1970. To put that reduction into perspective, imagine if a full-grown adult human male suddenly weighed just 65 pounds. If the average weight of our catches continues to plummet at this rate, the ocean will eventually be filled with fish that are simply too small to sustain global food demands. To reverse this genetic damage, scientists are proposing a counterintuitive solution to replace minimum limits, a model called balanced harvesting. Instead of focusing exclusively on the largest individuals, balanced harvesting works by catching fish across a much wider spectrum of ages and sizes. This distribution curve illustrates the concept. Fishermen would bring in a proportionally smaller overall number of fish, but they would extract them evenly from the small, medium, and giant size categories. By mimicking natural predation rates, this method preserves big fish genetic diversity and ensures those critical massive egg layers stay in the ocean to replenish the stock. It brings human consumption into alignment with natural ecological balance, rather than constantly fighting against evolutionary biology. But there is a major psychological hurdle to overcome. That 1376 method of imposing strict size limits is deeply ingrained in our collective fisheries management DNA. For anyone who casts a line or throws a net, harvesting medium-sized fish while letting the massive record-breaking prizes swim away feels completely wrong. Yet the real-world data shows we have almost no choice if we want to stop and eventually reverse the catastrophic halving of global fish weight over the last few decades. Humanity has to swallow its pride and accept the math. Letting the truly massive fish get away is the only way to rewrite the course of fishery.